Hey guys, so we're back with another video, and in the last video we talked about objects, a very important fundamental when it comes to programming, and especially object-oriented programming. Okay, so now we're going to talk about classes. All right, so classes are actually they haven't been around for so long, but they've been around since ES6, which I think came out a couple of years ago. So yeah, they're pretty much fairly new, and yeah, a lot of other languages have the concept of classes. And before, if you wanted to apply those kind of object-oriented style techniques in JavaScript, you would have to use functions. You weren't able to use classes. Okay, but classes are actually just syntactic sugar. Basically, it's just a wrapper around function constructors, so it doesn't really introduce any new ways, inheritance or any new paradigms, right? It's just the same. It's just a wrapper around the function constructor and the whole prototype-based inheritance thing, which we will get to in. I keep saying we'll get to it a different course because remember, I'm just trying my best to focus on the beginner stuff. We'll worry about the more advanced stuff later on. Okay. All right. So pretty much in general, like in the last video, I've mentioned something about a blueprint. Okay, so let's talk a little bit about that. So a class is pretty much just a blueprint or a representation or a template of some abstract type. And when I say abstract, what I mean by that is there's no limitation. It can be anything, right? It can be a blueprint of an animal. It could be a blueprint of a desk, a car, right? Notice how I'm referring to these kind of like real world entities because there is a relation between classes and objects, which I'm going to mention in a couple seconds. So for classes, you can define a class, you can you can define its fields, its properties, right, its methods, and then we can create an instance of that class. Okay, so I know it might seem a little bit weird right now, but once we get to a more better example, it should make a lot more sense. But pretty much when we were creating objects, think about how we were just creating the object and we defined its properties, we defined its methods, we defined all those things, and then we were able to play around with that object. We were able to reference its properties, we were able to call methods that were part of that object. We were able to do all sorts of stuff, right? Now the thing is, in JavaScript, it's not really like a full-on object-oriented programming language, but it does support object-oriented concepts. Okay, and the whole concept of a class is pretty much it's a way where we can reuse code. We can base our implementation off some kind of template. And remember, doing things with classes is no different than doing things with a function constructor. The only difference is the syntax. That's it. But underneath the hood, they work and function the same way. Okay, so when we have this class, you can think of it like a blueprint, right? It's just kind of like a base. And the thing is, though, we can have different instances. We can have different types of that particular class, right? Imagine if we had one blueprint for a person, right? Every person in the world is different. They have different, traits. They have different characteristics. They have different heights, weights, hair color, all sorts of things. Obviously, there may be some things that might be similar, but not every single person, not every single instance of that person is going to share the same traits, right? There might be some where they might share some things, where there might be completely identical, instances of a person, but hopefully that gives you a better understanding of the difference between a class and an object. So basically the class is just a blueprint, it's just a model. The person is the actual implementation of it. You can also think of it like a blueprint of a house, right? When you have this blueprint for a house, you just basically have like a foundation. You have the layout of what the house should look like. But not every house is going to look exactly the same, right? You can, some of the properties of a house, such as the color of the house, the amount of doors, windows, garages, bathrooms, all that kind of stuff, those are all properties of a house. And we can modify those properties. Like we can, let's say, for example, house A might be color red and house B might be the color green, right? House A might have 2 windows in the bathroom. House B might have only 1 window in the bathroom. It's these kind of things that I want you guys to think about when you think about classes and objects, right? These are different properties that define the object itself. Okay, and the field is really just the model, like the representation of that class. Okay, cool. So if we want to declare a class, all we need to do is just use the class keyword, and then we can name the class whatever we want. Now, one thing that I didn't mention in the last video is when we typically declare, function prototypes, or I'm sorry, using when we declare objects using the function constructor, or if we want to create a class using the class keyword, typically you'd want to capitalize the first letter of whatever the class name is, or the function, the object name is, just like how it's a class person. Okay. And we can also define properties as well, which I'm going to show you guys in just a sec. But we define the properties inside what's called a constructor. Okay, so let's go ahead and create a new file. And since I'm going to be creating a class, I'm actually going to give this an actual realistic name, or a more better name. We're going to create a class called house, or actually not house. I'll do computer.js. Okay, so we have our class computer.js, and we're going to go ahead and say, or our file computer.js. We're going to say class computer, and notice how I'm capitalizing the C in computer. You could, leave this lowercase, but it's always good convention to capitalize the class names. Okay, so right over here we just have a class, then we have a pair of curly braces, which pretty much defines the body of the class. So we're going to go ahead and use the constructor keyword, and we're going to basically create the constructor, and it kind of looks like a function right off the bat, right? So pretty much the constructor is used for initializing the object itself, right? We can initialize fields of this object. Okay, and typically, or actually not typically, but whenever you create an instance of a class, the constructor is the first you can think of it like a function, but it's the first function that is actually invoked. So the constructor is immediately called when you create an instance of a class. So what we're going to do is inside the parentheses of the constructor, we're going to pass in our parameters. Okay, so we're going to do the same thing, kind of like in the last video. We're going to take in, let's see, computer, what kind of properties does a computer have? Let's just see, I'm trying to think, computer has, I have a computer. I'm just trying to think of like reasonable properties, but it could be anything really. We can specify the case, we can specify the, I don't know, HDDs, or I'm trying to name it in the convenient ways, HDD, SSDs. Why is this? Oh, that's because that's a reserved keyword. We'll call this tower case. What else does a computer have? CPU, of course. GPU, fans. What else? What are other things? Power supply. So we'll call it a PSU. You can name these whatever you want. Okay, I think this should be good enough for now. Am I missing something? It'd be pretty embarrassing for a computer science student to forget one of them. Oh, motherboard. I can't believe I forgot that. Motherboard. The most important thing. It's been a while since I've built a computer. Okay, we have our main components. Okay, so what we're going to do is like in the function constructor, right? How we initialized our fields for our object. We're going to do the same thing. We're going to use the this keyword. So in this case, remember what I said earlier, the class keyword, right? The whole concept of class, it's just the same thing. It's just syntactic sugar over the whole function constructor. Okay, so this refers to computer. Okay, the instance, it refers to the class itself. Okay, so we're going to say this, we're going to call this tower equal tower case. You don't have to name it the same thing, but we're just giving the property tower the value of tower case. Okay, we're going to say this.hdds is equals to HDDs. This.ssds equals SSDs. This.cpu equals CPU. I'll actually leave this lowercase. This.gpu equal GPU. This.fans equal fans. This.psu equals PSU, and then we'll call it MOBO, motherboard. Okay, now one thing that I should mention is that you can actually manually set the values. Like you don't have to have values being passed in to the constructor like in the as parameters. You can just like manually set them, like, let's say for example this tower NZXT S340. That's my computer case. I can set like this, right? But obviously if you hard code the values in the constructor, it's always going to be this is always going to be the value of that property unless you alter it later on. Okay, and it doesn't really make sense to not assign it with a parameter. Okay, so let's go ahead and create an instance of our computer class. So we're going to say let my computer equal new computer. And we're going to go ahead and say for the tower case, we're going to say nzxt s340 HDDs. Or I guess this should be a count actually, because we'll just say we have 2 HDDs. We have 1 SSD. We have the CPU we have is I have an i7 67 oh wait, what was it, 6700K, I think, 6700K, 4.0 gigahertz. Hopefully I labeled this correctly. And then I think it's 4.0 gigahertz, quad core. Okay, we're not going to type the whole thing out. What else? GPU, I have a GTX 1070. Okay, we don't have to be super specific. But if those, when it's an EVGA it's an EVGA graphics card, or EVGA. Fans, let's just say I have, I think, about 2 fans in the front, one in the back, and I think 1 in the top, so 4. I mean, that's minus the CPU fan. I think I missed out one property, was the CPU cooler, but we're not going to worry about that for now. Of course, a computer would die if it doesn't have a CPU cooler. So PSU, I think mine is Corsair, I think. Corsair, I think it's 750 watts. Gold edition, something like that. And then the motherboard is an Asus Z170, I think, or I don't even remember. Asus Z170. Okay, cool. So we have all of our properties passed in. You want to make sure, double check to make sure that you pass in everything in the correct order. So tower case NZXT. We have 2 HDDs. We have 1 SSD. We have i7 6700K CPU. GPU is GTX 1070. 4 fans. Corsair 750W for the PSU, and then motherboard is the Asus Z170. Okay, so let's go ahead and actually log our object. So now we've created an instance of the computer class using the new keyword. Okay, and all of the fields over here, this.tower, this.HDs, they're all being set inside this constructor, and we're assigning it the values that we're passing in as parameters over here to the corresponding properties. So if I go ahead and do node computer.js, you're going to see that we have an instance of a computer, and you can see over here that on the first line it says computer, right? That's basically telling you the instance, right? Which instance of the object it is. In this case, this object itself is an instance of a computer. It is a computer. Okay, that's what it means when we say instance of. Okay, and then we have all of our properties that are set. Okay, they're all correct. Tower, HDDs, SSD, CPU, GPU, fans, PSU, mobile. Cool. All right, awesome. And yeah, that's pretty much it for the constructor. And like I mentioned earlier, the constructor is like a method that belongs to a class, and it's immediately invoked upon instantiation of a class. Okay, when I say instantiation, what that means is creating an instance of a class, and that's what we did right over here. When you use the new keyword, that means you're creating an instance of the class. Okay, cool. All right, that's just another example which I've done already. And other things to mention too, pretty much when we say fields or properties, that pretty much refers to the, I mean, you can call them variables that belong to the object. So for example, tower, HDDs, SSDs, these are all, variables or fields, right? They belong to the computer instance. Okay. Cool. So let's talk about methods, because I know I did kind of like talk a little bit about it in the last video with objects, but I really want to talk a lot more about it in this video, because this is a more appropriate video for it. So I've mentioned before that there really isn't much of a difference between a method and a function. The only difference is that a method just belongs to an object. Okay, and we've seen in the last video that we had one method in our person object as well as our car object, right? And that method was called display, right? Remember, all a method is just a function that belongs to a class. That's it. If you were to work in other languages like Java, you'll never use the word function, because all of the functions, right, they're actually inside classes, which pretty much that class has all of those functions, which again they're called methods. But don't worry so much about the whole naming stuff. Okay, you can use those two words interchangeably, but just know that sometimes some people, like more senior developers or more professionals, they'll probably confuse they'll probably be confused when you call a method a function or a function method. They'll probably assume that you're talking about object itself, which they're not entirely wrong to assume, but just keep that in mind. Okay, so we can use methods for all sorts of things. Kind of like, again, it's the whole thing, it's the whole same concept of functions. We can use functions to complete certain tasks. They're pretty much like subroutines that we can use later on whenever we want. Methods work the same way. Okay, so let's say, for example, I can create a method inside this class. Okay, we don't need to actually use the function keyword. We can just directly say that we can just specify the name of the method. So I'm going to call this, let's just say, get info, right? Or not get, display info. Okay, so we specify the name of the method, parentheses, and then curly braces. That's it. We don't need to specify the function keyword. Okay, because remember, technically this is not a function, it's a method, so we don't use the function keyword. All right, so now let's just go ahead and let's actually just log all of the information of our computer. And we're going to use the this keyword, okay? So I'm going to actually introduce to you guys something called template syntax. And we're going to use something called string interpolation to actually log our instance fields much easier. So to do this, what we want to do is instead of using quotes, right? Instead of using single or double quotes, we're going to use backticks. Okay, we're going to have a set of backticks. And what I'm going to do is I'm going to say name, or I'm going to say tower. And I'm going to use a $sign, curly braces. And I'm going to pass in the variable value that I want to actually log to the console. So this.tower. This is called string interpolation, and you're going to see it often. So definitely get used to it. Okay. And what else I want to do is I want to actually display everything else on its own line. Instead of having a bunch of console.logs, I'm actually going to use what's called an escape sequence. Yeah, I think it's called an escape sequence. Yeah, it's called an escape sequence character. And pretty much what it allows us to do, they're pretty much like reserved characters that we can use that have some kind of significant meaning. There's a whole bunch, but the /n pretty much skips to the next line. Okay, so if I want to display HDD, this is actually going to be on the next line. So it's better than just having a bunch of console.logs. Okay, so we're going to do this.hdds, and we're going to do next line. SSD, we're going to do this.ssds, and then we're going to do next line again. Remember, that's skipping to the next line, and we're going to say CPU, this.cpu, we're going to go to the next line again, GPU, this.gpu, I know it's a lot, I think it's very tedious, and then we're going to do fans, this.fans, and the next line, and then PSU, this.psu, and then next line, Mobo, this.mobo. Alright, that was very tedious, but you'll see what I mean in just a sec when I say it goes to the next line. Because right now you can see that right now we're logging everything. Okay, but let's actually go ahead and call display info. Okay, so let's get rid of that. And you're going to see that everything, instead of having it in curly braces, we're actually logging like the actual values to a console. Because before we were just logging the object. Right, but this time we're actually logging the values, that all the property values of that object. And you can see that we're printing out we're printing out tower, and it goes to the next line. If I get rid of this new line character, that's what it's called, a new line character. Right, you're gonna see it's gonna stay on the same line, tower, and then HDD. Right, it's a good way to format your text. All right, cool. And we've done that all with just one console.log. Another thing that I should mention that I didn't want to mention earlier because I didn't want to confuse you guys is log is actually a method that belongs to the console object. Now, console is actually a global object that you can use there's a lot of things that you can do with the console object, but we're not going to get into that right now. But the console object has a method called log, which we can use to pretty much display messages to the console. So that's just one thing that I wanted to mention. Alright, so we have the display info method, and all it does is just log stuff to the console. We can also do other things too. We can create methods that can update the values of our properties. We can also create methods that can also retrieve values of our properties. Okay, so whoops. And this pretty much refers to the whole concept of getters and setters. They're very, very, very important concept to understand in object-oriented programming. Okay, and when when they in ES6 when classes were introduced, getters and setters were also introduced. Okay, and the whole point of a getter and setter is pretty much the getter is used to get values. It's used to return instance fields. Okay, the setters are pretty much used for the opposite. It's used for setting or updating values of the instance fields. Okay, now to be honest with you, in JavaScript, it's kind of weird using getters and setters because most of the time in other languages like Java, which is a almost a fully object-oriented programming language, there's something called access specifiers, which pretty much what you would use to determine the visibility of a variable or a function, or I'm sorry, a method, right? In JavaScript, you don't have those kinds of access specifiers. Pretty much every single property, every single method is accessible anywhere, right? You can't. There's no way where you can't access a certain value because they're all public. Okay, so we're gonna go ahead and just I'm gonna show you a quick example of getters and setters because it is important that you guys do understand what they are and how they work. But yeah, okay. So what we're gonna do is we're gonna create a getter, and to do that we use the get keyword. And what we're going to do is we're going to go ahead and give this a name. So I'm actually going to call this tower, okay, in parentheses, because this is technically a method. But when we actually access this getter, we're going to access it as if it's a property, okay? Most of the time, getters are actually mainly used for computer properties, basically like, computing dynamic values, like adding two numbers together, like adding two fields together and then returning that. Okay, but you can use it for this way if you want. So we're just going to return tower because remember this is a getter. It's used to get the value of tower. Now, if we actually run this, we're going to get an error because what's going on is if we wanted to reference tower through the getter, we would say my computer dot tower. The problem, well, without parentheses. The problem is that it's referencing this getter, and then we're saying return this tower, but that's going to reference this getter again. So we're actually going to have something called a stack overflow. So we're actually going to change this property to underscore tower. Excuse me. Okay, so now watch this. So I can go ahead, if I log my computer to the console, let me actually get rid of this. And let's just log this again. You're going to see that the field tower changed. Now the getter is not displayed, right? But what I can do is I can say, instead of underscore tower, I can just say tower, right? And you can see that, oh wait, it's supposed to be this underscore tower now. There we go. And there you go, NZXT S340. So that's how getters work, right? The reason why I had to change this to I had to add the underscore in front of it, same thing over here, is because, again, right now we are referencing dot tower, which is referencing the getter, okay? We can also reference the property directly using the underscore tower, like that. And again, it'd be the same thing. So it really doesn't make much of a difference but getters are used for computer properties. And I'll leave a link in the description to the website where you guys can read all about it. But let's just show a quick example of setters. Again, setters are like mutators, or they are mutators. They're used for setting or updating or changing the value of an instance field. So let's just say, for example, we change our tower case, right? We're gonna say set tower, and the setter actually needs to take in a parameter. Okay, so we're gonna say just tower, and then what we're gonna do is we're gonna update this field over here, the underscore tower. So we're gonna say this underscore tower is equal to tower. Okay, so let's go ahead and actually use the setter. So to use that, we're gonna go and say my computer dot tower. Okay, so it's kind of like as if we were referencing the getter, but this time we're going to use the assignment operator and give it a value. So we're gonna give it a value of what are other cases that exist out there? NZXT 800. I don't even know what cases exist. I don't even know. We'll just say Corsair Carbon. That's okay. And now if I go ahead, if I log my computer dot tower, so I'm using the getter now, right? So you're gonna see NZXT S340 and then Corsair Carbon. So we use the setter. Okay, again, it's like, even though the setter is, it's basically a method, but we're referencing the setter as if it was a property. That's just how it works in JavaScript. In other languages, it's a lot different. So this is just kind of like exclusive to JavaScript. Okay, and there we go. We update the value of tower. Okay, so that's pretty much just a simple way of how getters and setters work. Okay, and yeah, here's another example with the car class. You can see we have class car, we have the constructor, and see how I have all of the properties prefixed with the underscore. Okay, because when we have our setters, typically you'd want to name the setter something convenient. So I could name it make. I could have named it something else, but I chose to name it after the field names. And since I'm naming it the same name as the field name, we have to change the field names and we have to add some kind of a prefix like this. Okay. And yeah, this pretty much just talks about getters and setters and whatnot. And now you don't need getters and setters because you can actually explicitly create your own methods that will do the same exact thing, right? So for example, over here, this is something that you do in a language like Java. You would create, getters and setters, but you wouldn't use the get keyword. So you would just create, a method called getMake, and then you would just return this.make. Okay, so I think that's it for this video on classes. I'm pretty sure we covered majority of the things that you would need to know on how to use classes, and hopefully I was clear on the whole getters and setters part. I know it's a little bit weird, but yeah, in my opinion, I don't think JavaScript is like the perfect language to really talk about object-oriented programming. I think it'd be better using a language like Java. Okay, but don't worry. We'll save all of the more. We're going to go deeper into object-oriented programming in a separate course. So for now, I think this is going to be it for classes. So I will see you guys in my next video. Peace.